Hi everyone, welcome to the stream. This is a stream about how to make a small graphical user interface, a little RGB color mixer in CircuitPython using a framework I've written. And the idea is if you have a PyPortal and you have it with you, you can code along to it, and that way you can go through the process of developing with this framework. And if you don't, no worries, I'll have the code posted online. And we can go from there. Okay, so can everyone hear me okay? And let's wait for a couple minutes before diving right in, just in case we have a couple people who want to join and aren't ready. We're going to be using some links in the broadcast, so if you're coding along, you'll need to download some software. And those links are going to be in the YouTube description. You can either download them now or download along with me while we're live coding. But, yeah. So in the interim between now and when we start, how about a little background information on myself? My name's Jonah. I'm a college student by day, electronics addict by night. I've been working with CircuitPython for about 4 years. And it's been so awesome to see the community grow and change in that time. I really learned how to code using CircuitPython. So, switching from that, this is my first live stream, so please hang with me if there are any bugs or technical difficulties. I'm sure if you've programmed before, you understand what I mean, or if you've seen live video, nothing ever goes smoothly. I also want to thank my friend, Ryan. He goes by Mango on social media, and he's been helping me with...
Hi everyone, I'm Mango. I'm the moderator here and kind of stream helper person.
Okay. Many thanks. He has a master of OBS, which I have no idea how to use, and has been a lot of help setting this up. Okay. So, can you tell me when it's about 1:05, please? And we can get started at that point. Okay.
Yep.
So I have a little example of what we're going to be making here in the bottom right-hand corner. It's going to be a little program on a PyPortal where we can mix colors and then see the output of those colors in hex here, and then what the color looks like. And this should take about an hour and a half, but we might go a little over, a little under. We'll have to see. Okay. Let's see. If there are any questions before hopping in, you can either post on the YouTube chat or you can post on the live Discord chat, both of which Ryan should be monitoring to keep me up to date.
I'll be checking YouTube more than Discord.
He'll be checking YouTube more than Discord. So if you have pertinent questions, ask away in there. And you can always say, I posted the code in Discord if you have issues with that. Okay. So, let's see. Okay. If you're interested in a little intro as to why I made the framework for graphical user interfaces, that's because I've been working on a couple projects that require them. A watch with a touchscreen and a tricorder from Star Trek. And those are kind of things you want user interface. So there wasn't a framework, so I thought I'd try to write one. And I think it's nice to use. So I figured, what's better than a big block of text and a guide for people who are visual learners? A video. So we'll have both available. Everything good?
I'm just setting some audio delays.
Okay. Okay. Looks like it's about 1:05. Shall we jump in? Okay. So now that we have an example of what we're making, a little RGB color mixer in CircuitPython on a PyPortal. We're going to dive right in. So first we're going to make sure our PyPortal is up to date. And we can do that by going to... let me open Chrome. Oops. Let's do this. Okay, here we go. Here we go. Let's take a look at Chrome. So to reset our PyPortal, we're going to go to CircuitPython.org, and we're going to download the firmware for it. And PyPortal is a board made by Adafruit. And what's really cool about it is it's a CircuitPython running board that has a display on it, which means you don't have to plug and do a bunch of wiring. Are you able to easily see the Chrome, or do I need to make it smaller? I think I need to make it smaller. The stream might glitch out for a hot second while I make Chrome smaller. I'm gonna have to do the swipe up thing.
Okay.
Okay. Here we go. So CircuitPython, for anyone who doesn't know, is a port of the Python interpreter written for microcontrollers. Microcontrollers are itty-bitty baby computers that, when we program them, we tend to use them for one thing. They aren't meant for like browsing the internet. They're just we need something to do a little bit of thinking and then talk to sensors and that kind of thing. And in this case, we're going to talk to a screen using our inputs. So now that we're on CircuitPython.org, let's go to downloads. And where is it? PyPortal. Here we are, PyPortal. And we want to download Python 6.0 or higher. We're going to go with Python 6.1 because it's always best to keep up to date. And then we're going to double click our CircuitPython board to set it into reset mode. And from our downloads, now that we see we have a reset PyPortal, we're just going to drag that firmware onto the board, and that'll make sure we're all up to date. And after that, we're just going to delete all the files and clear it out. Then we're going to download some new files. And those files will be the libraries we use for making the interface. Okay, so it looks like everything we set. I'm just going to drag these files to my trash. And now, and make a new lib folder. So, folder, lib. Okay. So now this is where the links in the description come in. If you hop on over on YouTube, there should be some links in the description, and we're going to download 3 libraries from Github and a couple libraries from the CircuitPython bundle. Let's see, where does this open? Okay. So let's see. We're going to download this. This is just a bit of a driver. Please pardon the semi-finished documentation. It's not all quite there. Now give me a moment to switch and open the next link. So these libraries are the core code that we use to write graphics on the PyPortal. And the things we're going to download from the CircuitPython bundle are going to be the libraries that Adafruit has written that this depends on. So Adafruit has spent a lot of time writing these very, very powerful, very fast display libraries, and we're going to build on top of that. Although don't worry, we don't need to concern about it. It's just what we need to download. So let's bring our folder system back. Let's make another window. And okay, here we are. So we'll have CircuitPython down here. Let's go into the lib folder, and then in downloads, we're gonna unzip these 3 files. Oops, double unzip that one. Okay, and we're gonna go into each one. There's gonna be a core folder or file in there. So we want TG-Gui core, and then we want, in the TG-Gui standard CircuitPython, we want to copy TG-Gui standard into our lib folder on the drive, and let's see, is it done decompressing? Here we go. There we go. Okay, and we want this TG-Gui PyPortal file, and this is driver code and the libraries we need. Lastly, we're going to use, let's open Chrome. Chrome is not behaving. Let's try. right here. Okay, there we go. We're going to go back to circuitpython.org, and we're going to go to libraries and download the 6.x bundle. And again, in the going to use. I don't have the list. Let's see. Give me a hot second to pull it up. So now I need to look at the description. Okay. So we're going to go to downloads and decompress the CircuitPython bundle. And I'm just going to use a search in Finder to find these things. So we are looking for the touch screen library. Ooh, looks like it's taking a second. Here we go. We're going to copy Adafruit _ touchscreen into lib. We also want ILI9341. We're going to copy the one with the Adafruit prefix again. We need display shapes. Display shapes. That's not how you spell shapes. And we need two more. So we need display text. 2 guesses what that does. Display text. Awesome. And lastly, ProgressBar. Okay. And after that loads, we'll open a text editor. Use your text editor of choice. Oh, maybe needs no space. Awesome. And we'll start coding. Okay, so it looks like that's all set up. Now we're just going to close this. I'm going to swipe over to my text editor. Let's take a look. Okay. Oops. Shh, you're not supposed to see that yet. Let's make a new file. We'll save it as code.py on the CircuitPython drive. I realize my window might be a little clipped, but hopefully you can still see it. Okay. So, before I continue, if there are any questions, throw them over in the Discord. Or throw them over in the YouTube chat. And yeah. Okay. So, first thing we're going to do is we're just going to make a very basic program. Thank you. We're going to make a very basic program just to get familiar with the anatomy of an app written in the TG-Gui framework. And first thing we're going to do for that... Oh, sorry. We're going to write a basic app, just get familiar with anatomy. It's just going to have one rectangle, center top, and then we'll play around from there. We'll break it into 3, and then we'll make a little slider, and then we'll finally compose all that together into the full project. So, first thing we do is import a library code. So from TG-Gui standard.all import star, and this is just a set of widgets that we're going to use. We'll describe that in a second. And from TG-Gui PyPortal. Oh, I might have forgot to mention before, I go by TG-Techie on all of my social media. That's the prefix. And we're going to import TG-Gui PyPortal as setup. So TG-Gui PyPortal is just a bunch of setup code pre-written for the PyPortal so that you don't have to write it. However, if you like this and you want to get it working on your stuff and you don't have a PyPortal, ping me on the Discord later, and I'll be more than glad to help write a driver for your display. Okay, so before we hop into writing the app, it's useful to know that in TG-Gui, everything you can see or everything on the screen is a widget, a thing. There are different kinds. You can have widgets that are for visual representation, like rectangles, buttons, pieces of text. And then we have widgets that contain other widgets, which we use to organize and group them together so that we can place them where we want to. So how we write an app is we write a class, which is an app. So let's call this class my app. Let's go with that. Actually, let's call it our app. We're going to subclass from layout. And the reason we're doing our whole app is just going to be a container, and we're going to lay out other widgets like rectangles inside of it. So there are 2 main parts of a app body. First is a place where we declare what widgets we want, And then after that, we declare where we want those widgets. So let's say our rectangle. So remember, we're making a single rectangle in the center top, equals rect. It's the name of the piece of code we use to make rectangles. And let's fill it with color.red. Okay. And so that's just declaring, hey, I want a rectangle that is filled with red, and I'm going to call it my rect just for ease of naming. After that, we declare where we want it with something called a layout method. Hopefully, it does what it sounds like. It lays out widgets. And so here, what we do is where we want them. So remember, in Python, self is going to be our version of our app. So we can say self dot our rect, and we call it first with a tuple, a pair of horizontal and then vertical position. So let's have it, right, we want it in the center for horizontal, and then vertical we want it in the top. And we're just passing these special objects in for right now. And let's make it half the width and half the height of the entire screen. So the way we do that is we can get information about what our rect is inside of using self. So we can say self, which is going to be our app dot width divided by 2, and self dot height divided by 2. And here we're using / instead of slash because we want integer division. The reason we want that is you can't put something halfway in a pixel, or you can't make something 1.5 pixels wide, right? Your screen has physical boundaries where you can place things. So everything's specified absolutely. And we're almost done. So this is the declaration of the app. Now we just need to tell the setup code, hey, setup code, please run this. And we do that just by decorating. So we say, at the top of the class, we're going to say setup dot app wrapper. And that'll say, hey, setup code, please run this when you run something. And at the bottom, we're going to say setup dot run, setup dot run app loop. And then we should see this boot up on the PyPortal. Give it a hot second. Made a syntax error. Line 2. I should have said import PyPortal GUI as instead of from. My bad. And typo as well. So line 10, I put outrect instead of rect. Can you tell this is live? Okay. Awesome. So if you take a look at the PyPortal screen down here, we can see we can play around with where we want that. We could do center bottom, and that'll go to the bottom, and then we'll do left bottom after that. And finally, let's try that. Left bottom. And there are more powerful ways of placing things, and we'll go into that after this. But before we do that, is everything sounding good? If there are any, take a short break in case you want to catch up with code, or if you want to ask some questions. And to drink a little water. Okay. Okay. If there aren't any, let's hop in.
Oh, we do have a question from YouTube chat.
Oh, yes.
It says rounded corners right out of the box.
Who asked?
Hugo Dahl.
So, hi Hugo. Yeah, so a lot of what's in this framework is sensible defaults. So we have rounded corners, but you can turn them off. And all you have to do is say in the arguments to rect. So inside of when we're declaring things, we describe how we want it to look. So we're going to say margin. Oh, sorry, not margin. Radius equals 0. And you can do like proportional radiuses and that kind of thing, but that's a little more advanced. So it looks like the code's loaded up. Okay. The idea is like a lot of things you'll want, but it'll be painful. You have to type it out every time, so why not make it default? And when you're there's more there if you want to customize. It's all you can customize pretty much anything, but we'll just stick with the defaults for now. Okay, so we have one rectangle. Let's play around with some more complicated placement, right? So what we're gonna do is modify the layout method, the any method, and from there we'll put 3 rectangles in the declaration, and then we'll move the 3 rectangles around to see what else we can do. Okay. So let's just start by duplicating these rectangles. We'll switch to a more boring name, rect1, rect2, rect3, and a more boring color choice, red, green, blue. But this should make it very clear for us to see. Okay. So we've declared we want 3 rectangles, 1, 2, 3. Now we're going to place them. So first thing we're going to do is we're going to duplicate our code here just because that's pretty easy. Oops. And don't tell anyone I'm copying and pasting code. 1, 2, 3. And we'll just throw them in different corners. Left top, left bottom, and then right bottom. And we'll see how that looks.
Hugo Dahl in chat has said, sensible defaults, recognizing the typical needs of the end user. Good stuff.
So yes, Hugo, that's the goal. The goal is to make this super easy to use, but powerful when you need it. And that goes into a lot of the design philosophy for the framework. You can do whatever you want. But generally, most people do things where, stuff you can predict. Or stuff you can accommodate for. That's a better way of putting it. Okay, so it looks like we have our 3 colored rectangles on the screen. They're a little larger than I want. So let's make them smaller. Now, here we copy and pasted self.width /s2, height /2, a bunch. And that not only looks bad, but it's duplicated code. We don't need to. So what we are going to do is just save that locally as size. Actually, it's called rect size to make it even clearer. And we'll just copy and paste this. I also don't like that I fill the whole screen. I think it would be a little easier if we make them smaller. So let's make them each a third of the screen size. And then we'll just put that down here. And for ease of reading again, because we're trying to make this easy to read, easy to write, we're just going to put these all in one line and then describe what it is, right? So we want the left bottom, and it should be the size of a rectangle. And one last one to convert. Oops. Rect size. Okay, so that should resize them all. And I think it makes our code a little more readable. Let's see how it works on the PyPortal. Awesome. Okay, so they're just a little smaller. Now, next thing we're going to do is a bit of a shorthand, but is, again, to make our code easier to read. So we're going to place rectangles relative to each other. And to do that, we need to reference them. So if we wanted to put rect2 below rect1, we'd want to use the name rect1. So there's a shortcut here where we can say rect1 equals. And basically we're saying, hey, when you're done placing this, I just want to use it quickly here. So we're going to do that for each of these, rect2 and rect3. And so that won't change our code functions at all. What we're going to do is let's put them vertically. We're going to do rect1, rect2, rect3. So all we have to do here is say, I want rect2 below rect1. And we're going to put rect3 below rect2. And save. Okay, so it looks like the PyPortal loaded it properly, which is awesome. And you're not limited to below. There's a bunch of things. So what we're doing here is we're using something called a position specifier. And 2 guesses what it does. It specifies the position of a widget. And these ones specify relative to another. So we could put the blue rectangle let's put it to the right of rect2 and watch it recalculate that size for us. See? Okay. And here, all of our sizes are the same. They don't have to be. That was just for example purposes. So let's make this a little longer. Let's make it half the width. And then, oh, that's the height. But still a different size. You also don't have to anchor all of them off the same one location. If we put, so we could have multiple anchors, the anchors being like rect1, and then go from there. Again, I'm gonna pause if you have any questions or if you want to catch up, if you're coding along, and then we'll go from there. Additionally, we're just going to be using rectangles and some sliders and text today. We're not going to be doing some of the button stuff, but it's all in there. And the standard library is only growing. Not that it's growing quickly. But. Okay. Ooh. Don't want to spill water all over everything. Okay. Looks like I'll continue. Okay. So after, let me just check my notes. Okay. After this, what we're going to do, okay, we're going to scrap the rectangle thing. No more our app. What we're going to do is we're going to make a piece of text and a slider. And then we're going to make the slider reflect where your, we're going to make the text reflect where your slider is. So we're going to take this in 2 steps. Let's just put a text and a slider on the display. We'll start with text, we'll do slider, and then we'll build from there. So let's rename this as much as it pains. Just to app. We're going to delete here for now. Right. So let's declare text. So in TG-Gui, a single line or a single text is called a label. So our label is just going to be label. And again, when we're declaring, we declare the name and what we want it to look like. And we want it to say, can you, oops, the text to be, can you see me? And then remember, we need to lay everything out once we declare it. So our label equals self dot our label, and let's put it in the, again, center top. Let's make it full width, half height. Self dot width, oops, thank you, Adam. Divided by 2, self dot height, HEI, divided by 2, and then we'll just see how that looks. Okay, PyPortal's loading it up now. Yes, so I can see it. Hopefully you can as well. Yeah, awesome. So this is kind of like a rect, it's just a little different. Instead of being a color, it shows text. Now we're going to add our slider. 2 guesses, but we're going to call it our slider. And the way we declare this is saying slider, and we pass in what value we want it to represent. So we want it to represent some data. And to do that, we need to link our slider to a piece of state. And we'll go into what and why state is in a moment. So let's say some data equals our state. And sliders use floats. So we're going to start at, let's say 0.5. And we say, 0.5. So now our slider equals a slider with our value equal to some data. And then we just need to place our slider. So our slider, self.our slider, we're going to put it below, we'll probably spell that correctly. We're going to put it below our label, and we'll make it the same size, and I'm going to copy and paste, just because that's quicker. And let's take a look. Ooh, looks like I mistyped something. Line 16. Oh, I'm forgetting parentheses. Okay. Don't you hate that? Okay. So, I forgot to make it full width. So, one cool thing about integrating TG-Gui with CircuitPython It's not locked to that, but CircuitPython has a very fast iteration time for when you're trying to do things. So we get the advantage of all of that with the fact that the GUI boots up quickly. Okay, so now we can see we have, can you see me, and a little stateful slider. And now we're going to do, what we're going to do is make the text mirror the slider value. Again, we'll do a small pause if you have any questions or if you want to ask about label or positioning again. But we'll hop right into explaining what state is after that. Okay. So, what is state? State is a way of let me rephrase that. State is a way of managing what data your program displays. So your program with state will take in information, process it, and then change what it shows. In our case, what we're going to do is we're going to take in the value for the slider, turn it into something that text can show, and then put it in the text. So the way we do that is using something called a derived state. We're just going to put it right inside the label instead of the text. So we're going to see a derived state. And derived state takes 2 arguments. First, what we want to derive from. So we're deriving from some data. And then how we want to derive it. So let's make what we show, say like the value, colon, space, and then a rounded version of the sum data slider. So what we're going to do that with just a lambda function. You can do this with a normal function. So it's going to take in data. Sorry, excuse me. It's going to take in data, which is the value represented by the sum data state object, and we're going to put it into a string. Say value colon space, and let's just round it off so it's not a gajillion digits long. Round data d for our lambda function. Let's give it 2 and see how that looks. I'm going to just break the line a little bit so it's easier to read. And 100 instructions executed. Accumulator on the board. Looks like it works. So we have it mirrors a value all the way up to 99, and I think that's just because, yeah, because I wasn't touching it all the way to the edge. We can go all the way down to 0. Yeah. Are there, again, I'm going to pause for any questions. I know that was a good amount of information. And some water. So this state is something we're going to use a lot going forward. We're going to take data in, derive some other data based on that, and then use that to affect our output. And remember, we're going to use that to build our RGB hex mixer. Okay. If there aren't any questions, I will just continue on. Okay. So sadly, let's delete what we've done so far. Oh, no, actually we don't need to. We'll just keep some data. So as a quick reminder, what we're going to do in this next stage is the color mixer. We're going to put on the top left-hand corner a little rectangle with the color you're mixing. On the top right-hand, the hex representation of that color in RGB format. And then below it, 3 sliders, one for R, one for G, one for B. Before we do that, let's make this slider just a little bit less wide, because right near the edge of the screen, it's a little hard to touch. So let's say we'll divide by, we'll just make it 9/10 of the width of the screen. So here we're multiplying by 9 first, because we want that integer division to really, again, keep integers for the dimensions. And let's do a break line. Again, keeping things readable. Awesome. So we see our bar starts a little farther in from the edge, but we still touch all the values. Okay. So let's start by just making the 3 sliders, and then we'll link them to the rectangle and that kind of thing. So let's rename this R slider. We'll make a G and a B slider as well. For now, let's link them all to some data. Oh no, we'll make RGB. So we'll make an R, a G, and a B state. They're all going to start say 50%. And I'm using this comma stuff just to make it cleaner to read. You don't have to. You can do them on separate lines. And that we need to update these to R, G, and B. And again, we're gonna update RG, B, and now we change the layout method. For now, let's comment out the label, and we're just gonna focus on the sliders. So we have our R slider and our size, but we're gonna use the same size for all the sliders. So let's make a variable for that. Slider size. We'll say sliders. For all the coding hours, it still can't type. Slider size equals. Let's make it. Okay, so we need 4 rows, right? An output row and then 3 sliders. So we'll make it the full width, or the 9/10 of the width. So 9 by self.width divided by 10, and then a fourth of the height. So self.height divided by 4, and we'll duplicate our placement line for each of them. And we'll just change these. RG, B. Okay. So right now we need to anchor these to something. We'll put we'll put the R slider center top, and then we'll put the below. We'll put G below R and B below G. And again, let's see how that renders. Awesome. Okay, so here we have our 3 sliders. Next to do is make a derived state that represents the color based on these. So I'll take a small pause for water because I've been speaking for a little while. Okay, so let's hop in. We're going to put a rect and a label. Let's just start with a rectangle because that's going to be a little more complex. So, what do we call it? Color sample. And I'm not using just the term color because that is some default code provided by TG-Gui. Because you can say like color.red.blue. We're actually going to use that here as well. So we're going to make a rectangle. And we want the fill to be a derived state later. But let's just start with color.green. Or color.white. Let's do that. Color.white. And we're going to put it top left. We want it to be quarter the height, half the width, so we'll make a sample size, right? It's going to be self.width divided by 2, self.height divided by 4, and then we say, now we lay it out. So color sample equals self dot. We're going to pass it top, right? Top left, and then sample size. And right now we'd have it on top of the slider, so let's put the slider below the rect. Below color sample. Oh, I swapped my things. X then Y. Left, top. My bad. Awesome. Okay. Looks like that's a little odd, but that should be fine. Okay. Actually, we're gonna put this centered and below. So.
Oh, there's a question from Hugo Dahl again.
Sure, Hugo. Well, what are you curious about?
If you have elements overlapping, does the later top paren 1 take priority?
Later paren.
I assume later in
okay.
the code.
Yeah. So if you have overlapping widgets, which you shouldn't do, but you're technically allowed to, is the one that's placed later will be on top. And you can take advantage of that. So if you want to add a border around something, what you can do is you can place the border first and then the thing you want after. And there's some cool ways you can combine that with changing defaults so that it does auto sizing for you. But that's more complicated stuff. Okay. Did that answer your question? And in the meantime, I'll just start writing out the label. Surprise, surprise. We can just reuse our code. Okay, so let's call this hex out. And for anyone who isn't aware, hex is shorthand for hexadecimal. It's a way of representing numbers using less characters. And instead of having 10 values per digit, like we have 0 through 9, it has 0 through F. 0 through 9 and then A through F. So that's just a quick way of seeing the colors.
16 digits.
What did I say?
You didn't say.
Oh, sorry, 16 digits. Okay. So our... Oh, no, before the label, I forgot, we're going to make the rectangle follow the color of the sliders. So if we move that over, we should see more green than red and blue. We're going to do that with a derived state. And you don't have... We're going to write it under the RGB. This might be a little confusing, but we're just going to call it RGB, and it'll be derived state. And we want to derive it from these 3 separate R, G, and B variables. We can do that with just a tuple of R, G, and then B. And then we're going to use another lambda. And we're going to take in R, G, B. And then we're going to use a function that comes with the TG-Gui library by standard, which is color. Right, because we have floating point decimal numbers. We want to convert them to a color, which is representable in an integer. So we have color dot from floats, and that way we just pass RGB, and then we need to change fill to say, hey, we want you to be filled with this, and let's take a look. And loaded, awesome. So let's make it all red, and then so it's working. We can see that it still responds quickly, even though we have multiple things updating. And hopefully you also find it pretty readable. I know I do. And again, if you have questions, just throw them out. So what we're gonna do is we're gonna make our label have the hex representation of that color. Python has a built-in function for this, so we're going to make a derived state. Can you tell they're pretty useful? Sorry. Mango's telling me to slow down a little bit. I guess I'm getting a little excited. Okay, so I'll say that. So now that we have a rectangle working, we're going to make our text that goes on the top right corner, and it represents the same color but as a hexadecimal value. And again, we can do this by deriving state from the RGB integer. So we're just going to take in RGB as our base state, and then Python has a default function. We'll take in RGB as the argument as well. And its default function is just called hex. So we're going to call hex on RGB. And that should do the trick. Oh, almost forgot. We also need to place hex out. So we'll do hex out equals self dot. Again, so we've declared what we want. And we're saying where we want it down below in the layout method. And we know we're going to want it on the right top and sample size because it's a sample. And let's see how it loads up. Looks like it's working. Yeah. Any questions or any concerns? Okay. I know that was a lot of information. If you want me to slow down and go through any of it again, I'm more than willing to. Or any curiosities, just throw them out there. Oh, thank you, Hugo. Hugo said, no question or concern, just impressed with the slickness. Thanks. So I've been working on this framework for, in total, about 4 years. This version, months. But I've done several revisions, and it's gotten easier to use every time. And that's the goal, right? Because there are bunches of ways of making graphical user interfaces, right? But I kept on making something and then having it be harder to use. So I kept on trying to refine and make it fun, approachable, and intuitive. Oh, okay. That's a great question. In theory, yes. Have I programmed them to do that? No. So, I can give a more technical answer than that, but it'll go into a little bit of how the back end of it works.
Discord chat too.
Oh, let me check the Discord chat.
Here, I can show you one here.
Oh, that's a great question, Foamy Guy. Foamy Guy asked, what other kinds of widgets do you have already? So I have coded for CircuitPython, rectangles, buttons, sliders, labels. Actually, let me check. So actually, I can do this and show you. We'll go to CircuitPy, lib, TG-Gui standard. Here are all the ones that I implemented. ProgressBar, rect, slider, label, button. I'm looking to implement others. So I want to make a toggle, which is like those little toggle widgets on macOS or an iPhone where you click them and they slide back and forth. And if we were to render this on the computer, you'd use the same toggle and it would look like a checkbox, hopefully. Okay, let's see. Slider is looking nice. Is it built from ProgressBar or more from scratch than that? Great question. Slider is built from ProgressBar. So what Foamy Guy is asking is what underlying display.io CircuitPython libraries am I using? I'm using, for the slider, I'm just using a rect and a ProgressBar and doing the manual calculations to update them at the same time. And that's easier than replacing a rect every time, because if anyone who's familiar with CircuitPython or display.io knows, things don't like to change size, which is good because it makes our code fast.
YouTube chat, Cedar Grove, says relative object placement is excellent.
Thank you. It's one of my favorite features. You don't have to do relative though, so you don't have to use a position specifier. If you want, you can do pixel perfect placement. You could place a rect exactly where you want it, but the idea is sensible defaults. There are some enhancements that I have yet to make and want to make things even nicer, but I think it's usable as is. You can also code your own position specifiers, but that's, again, diving a little deeper. Yeah. Okay. Actually, to the vertical slider thing, that's a great point. I should make that. Although I'd prefer if there's a way where instead of having it be separate versions, you pass an argument. I just haven't figured out how to do that yet. If you know how, I'd love some help. Yeah. Oh, let's see. Do you crash? And I thought this might be interesting. You aren't limited to using this code on this device. So in my free time, not PyPortal time, I've been working on a CircuitPython watch.
This camera.
Sorry. Thank you. Working on a CircuitPython watch from scratch, and that was the main inspiration. Oop. Looks like it's not linking.
Pretty centered under
there. We go. Okay. I've been working on a CircuitPython watch from scratch, and that was the main inspiration for making this, because like I wanted to. Watches are tiny, and I don't want people to have to hard code their pixel placement for a watch, because then you can't reuse it. So last night I loaded this hex mixer onto the watch. So as we can see, this is effectively the same code, different variable names, but who cares? And we can mix colors on both. Closed it. The watch is a little slower to update, because there's some hardware stuff, but we're not locked into. You're not locked into a device, and I think that's something that's pretty common with many interfaces for writing graphical user interface frameworks. Often you have to hard code for an application, like a specific device. Thank you, Foamy Guy. I'll take a look at that. I didn't realize K-Match had published their toggle. I knew they were proposing it. Also, thank you, Haxer. Is that supposed to be like an I for the one? Nice. Thank you. It's been my baby for the past 8 months.
More than 8 months, and can confirm on the baby thing.
Okay. Yeah. If you want to see an example of a button, we could do something with that. But we don't have to. That's going beyond what was scheduled for the live stream. Oh, I forgot to mention, all the code is open source. It's licensed under the MIT license. Go have fun. And where my documentation is wrong, please pull a PR. And yeah, so it's usable, but there are corners of it that need like documentation and more thorough testing on multiple devices. The project's also segmented, so you don't have to understand the whole thing to work on it. You can understand a little bit and just fix that layer, so you don't have to, like, it's not a huge buy-in if you're curious. Okay.
I'm keeping tabs in the menu now.
Thank you. Okay.
We're about done.
Yeah, I think we're about done. That went a lot faster than I expected. If I was speaking too fast, sorry. There is all this code, the different stages we wrote, is available for download. It's linked in the description. It has a little more. It has actual comments where this doesn't, although hopefully it's readable without them. Fingers crossed. And I'm working on a textual version of this guide, but that's not done yet. I'll throw it in the description when it is. Yes, Mango?
I'm listening to you on a 12-second delay.
Oh, that must be painful to hear. Okay. Hugo Dahl said, that went a lot faster than I expected. I'm sure that will be voiced by folks using this library. Thank you. It also went a lot faster than I expected. So when I was first figuring out what I wanted to stream here, I was like, what if I do a color mixer? And I said, okay, I'll test my library by doing that. I was surprised doing it from scratch, and I was skipping right past all the intermediate stages. It only took me 20 minutes. Granted, I'm familiar with the library, very familiar, maybe too familiar. My friends can attest to that. So that helped me with the speed. But I find it's pretty easy to go fast. Sometimes you need to slow down if you like put something incorrectly. Oh. Sorry. Oops. Hugo pointed out what he was saying was a quote of mine. My bad. Okay. 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 Unless there are more queries or requests, I can stay on here for longer or turn it off. I'll say another minute or two, and unless there's something you want to see, or like if you want to come up with an idea and we can hack it out quickly, because it's live. Provided Mango's up for that.
Sure.
Okay. We could make a counter if we wanted to, or something. Yeah. Oh, and a reminder: if you want to run this on your board, and it's not a PyPortal, ping me, and we can work together to get it working. It's not a lot of code, but you just need to type it out. Mostly copy and paste. And yeah. For everyone who tuned in, thank you for taking the time out of your day to come take a look. I hope you enjoyed it. And if there's interest, again, in seeing more of these things, just ping me. Yeah, okay. I'm gonna a little more water and then see what we should do. Okay. Everything good? Okay. Thank you for tuning in. I will see you in the future. Let me turn it off.
Nope, I do that.
Oh, you do?
Yep.
Awesome. Bye, everyone.
Bye.